Hi, thanks for coming. I've tried to put something I think will be interesting for you together, but we'll see. Yeah, okay, so my background, I worked on something called ILEC back in the day, which is now British Gas Hive product. Then I spent some time at ARM working on their Embed and Pelion device platforms, and a lot of time working on their update solution in particular. Then I worked at IR Systems on they have a secure programming solution. And that all kind of led to me having an interest in supply chains and how you can secure them. The last year or two, I've been chairing the IoTSF's working group on supply chain integrity, which updated. We put some updated requirements. We updated the assurance framework about a year ago, and earlier this year we published a white paper which really explored the supply chain in a lot of detail. I'm going to draw on that in this talk, but I'm just going to give you a kind of bluffer's guide. All right? So I'm just going to focus on. I mean, that paper has. It has a really methodical approach to working out a risk-based look at what are all the possible attack vectors and what might you want to do about it in order to eventually justify the things we put into the assurance framework. But what I'm going to do now, I'm going to give you a quick overview of what supply chains look like to help you orientate quickly if you haven't already got that, and what you might want to worry about and do about it. And that's the link to the paper if you want to get the detail. I'm an attacker. Okay, if you're thinking, get me out of here, you've got 15 more minutes. Who am I? All right, so I could belong to a bunch of different groups. Maybe I'm just a freelance researcher looking to make some money out of some 0 days. Maybe I'm a dodgy contract manufacturer and I want to make some extra money by abusing my access to your IP, or maybe I just want to steal some personal data. But let's say I belong to one of the two most resourceful and motivated adversary groups, who are capable of compromising IoT systems, and doing so is definitely going to generally advance their goals. So APT groups, they're all about spying and sabotage, right? And a lot of the most kind of spectacular attacks that we see come from them, even though they're a relatively small group. Maybe they're probably 10 times smaller than the other group, ransomware groups, but those guys are also extremely motivated, mostly because they've been so successful, right? And they're all about extorting money, and they develop this great business model of infiltrating critical systems, pulling the plug, and then holding organisations hostage until they pay up. So I mean, they've also got a lot of resources and motivation. So really, your next question is probably, why should I attack you? Are you really on my radar? And well, you might be. Right? If you've got money, if you've got cash, and you would be highly sensitive to having your operations disrupted, then you're a target. If you operate critical national infrastructure, then you're a target. Or if you handle lots of sensitive, especially personal data, then I want that. You're a target. But maybe the thing about supply chain attacks is that you can be at risk even if you're not doing any of those things, right? Because if any of your customers is doing any of those things, then I might attack you because you're a way in. Right? And it's worse than that, because if your supplier supplies any of those targets and I attack your supplier, you can easily become collateral damage, right? So you got to think about that when you're worrying out whether you're really going to be a target. In case you need convincing as to that point, let's take a quick look at how many supply chain attacks impact multiple victims, including people who aren't actually the target. And it's really pretty much all of them. In fact, for me, the attacker is really one of the most attractive aspects of a supply chain attack. With one compromise, I can fan out and compromise a really large number of potential targets. Take NotPetya. targeted at Ukrainian financial, energy, government systems, but it's notorious for its utter indiscriminateness. So it found out and ended up compromising systems all over the world. And as far as I know, it's still the most expensive in terms of assessed damages attack in history. SolarWinds, actually, probably not coincidentally from, I think from the same group, but yeah, the SolarWinds attack compromised 18,000 different businesses in order to, of which only 100, I say only 100, but I mean, all of that was to extract US government secrets, but everyone got hurt. So you can't, and and note also that it's not really safe to assume that there aren't many supply chain attacks, because really there's a lot, maybe not all in IoT, but I mean, just in general, and there's plenty of statistics out there about how many are happening, especially in the open source sector where libraries get compromised. Okay, so the last argument you might have for not being worried about supply chain attacks is that why would I attack your IoT devices when I could attack? I mean, for me, it's going to be more work to do that. Quite likely, it's going to be less return. So instead of attacking this tower, maybe I can just attack the front door. I mean, why your IoT devices? And actually, that's not a bad argument. In fact, it's a really good one. But the problem for both of us is that neither of us knows if it's true. The closest either of us can get to knowing if that's true is by building attack trees for your entire organization and then analyzing to work out which are the most cost-effective ones. And that's a really powerful method, and you can, if you want to read about it, there's some more in the white paper, but it's a lot of effort, and you might not have the resources available to do that. And even then, it's not perfect. So it comes down really into what is one of the hard problems in cybersecurity, which is where should you put your effort? Or put another way, where should I put mine? So I'm going to decide that based on what's worked for other people and my own experience and gut feeling. So maybe the more I've worked on IoT systems, the more likely I am to attack you. The more your IoT systems or products are supporting like really critical applications up to and including protecting human life, then the more likely I am to attack it. And the more customers you have, the more likely I am to attack it. And at some point, then it could happen. So let's take it as a given that I've decided to attack you via your IoT supply chain, your devices supply chain, I should say, or else I'm going to attack you because you are in the supply chain of my target. What am I actually going to attack? Let's take a quick look. This is a generalized IoT supply chain, IoT device supply chain, sorry, I should say that. So going from left to right through the process of development and manufacture, you see it pulls together a bunch of different kinds of assets through a bunch of different operations to create a functional device. And then this last bit is really distinctive of IoT device supply chains compared with ICT supply chains in general, and that's where in the supply chain, in the factory usually, then those devices are placed into trust relationships, cryptographically backed trust relationships with whatever systems and people need to deal with it. And we can break that down another layer, another step to break out some specific operations, assets and tools. And again, if you're interested, there's more detail in the paper. So if you look at who deals with those, you see there's a lot of different actors in that supply chain. The assets pass through multiple people's hands who operate on them with multiple tools in multiple different environments. And the fact is I could try to compromise any of them, anywhere. They're all potential targets. So which am I going to choose? My aim, I want to achieve a remote exploit on lots of targets for little effort, and I don't want to be detected before I can launch my attack. So if you ask me, you might get different answers from different people, but I think there's three areas which deserve a lot of. Well, I'm going to start my search in those three, and funny enough, they actually really aligned with Rob's three. So one is update systems. Update systems are great, and there's been lots of attacks on update systems. Because, I mean, they're great because people generally just accept over-the-air updates. I mean, and they're really not as protected in general as they ought to be, given the amount of damage that I can wreak if I compromise one. And I get complete code execution ability once I've compromised that update system. So either the code signing system or the update distribution system or both. Those things are super, I mean, I'd love to compromise that because that's going to help me a lot. The second place I'm going to look is in your software supply chain, like probably through your, I mean, either your own application development, but more likely one of your platform suppliers, library vendors, because that's not something you have oversight of, and it might, I mean, it's really hard for you to have any idea, no matter what your own quality assurance processes are, like what anyone else is doing. So again, it's a kind of shady area that isn't subject to a lot of scrutiny, and it's going to be a little harder for me to build an exploit based on it. I'm going to have to choose my library carefully, maybe be a bit ingenious in how I exploit it. It's not full code execution, but it's not far off. And third area, which is what we're talking about actually, is the programming. Well, I call it provisioning, so it's a bunch of operations. So programming, personalization, and onboarding, right? And like the other areas, and maybe Rob can help me here, but I'm not aware, actually, of a lot of examples of this area of device credentials being hijacked so far. Maybe I'm just ignorant. But from my experience working in this field, then it's these provisioning operations and the assets and the credentials used to do it are really badly protected. They're often in manufacturing environments, open to anyone who walks in, and yeah, I mean, especially for an APT group who might be able to require the cooperation of a contract manufacturer on their soil, then it'd be a piece of cake to basically completely undermine your ability to trust any of the device identities. So that's really important. There's just a couple more things to say about those two. I mean, none of them are easy to spot before I use them, right? And all of them deliver lots of vendors' devices, maybe multiple vendors' devices to me. So the one thing about the third-party libraries part, which is that really the point of attacking your supply chain is to introduce a vulnerability that I can exploit in your deployed systems. But the thing with third-party vulnerabilities is that I often won't need to go anywhere near your supply chain. I don't have to bother because I can often find a vulnerability that's already known and present. And indeed, exploits of known vulnerabilities are a leading source of hacks in other domains. According to the Pono instance, 60% of data breaches involve unpatched vulnerabilities. And that's just because it's really hard to keep up with patches when you have a complex system. It's just a big organizational challenge to keep track of them and then to get them out. And even if you're good at that, it takes time between a vulnerability being announced and the patch coming out, and then it has to percolate down through however many layers of the software supply chain it needs to reach you. So they're effective because even after patches exist, the vulnerabilities remain live in deployed systems. They're also really cheap for me because often they often come with an exploit kit, so I don't even have to develop that. All I have to do is find a vulnerable system. So it's not just me you need to worry about securing your supply chain against. You need to worry about your supplier's commitment to maintaining and delivering quality software, because it's that quality essentially is indistinguishable from security, because at the end of the day you can't tell the difference between sabotage and a bug unless it's a really obvious backdoor style sabotage. There's a really great talk I think last year from FireEye about Huawei, and they've done a real in-depth analysis of Huawei's software and said there aren't any backdoors, but you know what, it's full of vulnerabilities anyway. And can you really tell the difference between that and a deliberate sabotage? You can't. Okay. All right, so just to wind up, still doing the Bluffer's Guide here. If you want for the details, you can look in the assurance framework or the white paper. But I mean, these are the key kind of activities you need to think about, either as a supplier in the IoT supply chain or as a consumer of products in the IoT supply chain. And they kind of mirror each other. So let's say you're shipping products, then ship your supply chain, ship some documentation of at least your own supply chain, like who are your suppliers, what do they do for you, what are your own processes. So that's the next one, which is you follow a secure software development lifecycle and quality practices and provide some evidence of that. Make sure you secure your assets in production. So it's not just the code base, but your personalization credentials. So if you're producing devices, your manufacturing environment is also a production environment, and it does have assets which need securing. And as like I said before, your code signing process probably needs more careful control than a lot of people are giving it. And finally, you should be making a commitment to maintaining your products and following vulnerability disclosure best practices, which you can also read about in the IoTSF. If you want more details, then there's a bunch more specific recommendations in the assurance framework, which was, as I said, it was updated at the end of last year, specifically, largely to include improved supply chain stuff. And there's this from NIST as well, which was released in February. The latest version of their secure software development framework, also specifically updated to address supply chain attacks better. And actually, in consequence of the SolarWinds attack, which led to an executive order requiring NIST to provide this, and this is their response. That's it for this. I hope Matt provided you with some context or interest. So thank you very much. If any questions, I'm happy to take them.